So I wanted to film this lesson on radical expressions to help you understand actually what it is that you're finding and how to simplify it properly. All right, so let's go ahead and take a look at radical expressions. So the first thing you need to understand is that a radical, the square root symbol, is the opposite of squaring. So what that means is if I square this 3 and I do 3 times 3, that's going to equal 9. The opposite is if I take this 9 and I take the square root of it, I'm going to get the answer of 3. So understand squaring and this radical mean the same exact thing. Okay? Radicals are typically used with perfect squares. Okay, so 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5, and so on and so forth. All right, so we need to understand that we need to recognize these perfect squares first. Our list of perfect squares would be 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 16, 25, all right, 36, there's 6 times 6, 7 times 7 is 49. Then we have 64, 81, 100, 11 times 11 is 121, 144, all right, so then we have 169, 196, 225, and the list goes on and on and on and on forever and ever. Once you have kind of mastered these first 15 perfect squares, it makes understanding radicals a little bit easier. So the square root of 81, what two numbers when multiplied by itself make 81? Well, that's 9 times 9. So the square root of 81 is the number 9. 196, what two numbers when multiplied together make it? Well, that would be 14. 14 times 14 make 196. Now in this lesson, it's not actually asking you about the perfect squares. It is asking you more so about non-perfect, so our irrational numbers that we're dealing with. All right, and that is kind of stating that radicals that are used with these other numbers can be simplified if there's perfect factors within it. Okay, so for instance, if the number 9 is in it, that's a perfect square. If the number 16, if the number 25, if the number 4, if you see those perfect square numbers within it, that represents that it can in fact be simplified. All right, so what we're going to do is we're going to take a look at how to kind of simplify and what this actually means. And I'm going to go back to the days of 6th grade when you created factor trees. Okay, so let's go ahead and make a factor tree for the number 132. All right, so I see right off the bat that 2 can go into this. So I'm going to say 2, and I believe that would be 66. All right, then I go from there and I'm like, okay, let's get this a little bit focused, huh? All right, I can say, well, 66, we have the number 3. Excuse me. All right, and 22. From here, I can go, oh, okay, I have 2 and 11. So the numbers 2, 3, 2, and 11 make up 132. So the square root of 132 is 2 times 2 times 3 times 11. So now what I'm going to do is I'm going to analyze these factors. Again, I'm looking for perfect squares. And I'm also looking if there's a repeat of a number. So 2 times 2 would be perfect because 2 squared, right? 3 and 11 can't be combined any further. So this would then become the square root of 4 times the square root of 33. And all I did was combine this 3 and 11 together to make 33. 4 is a perfect square, so the square root of 4 is 2, and we get the square root of 33. So the square root of 132 would simplify to be 2 times the square root of 33. Okay. So let's go ahead and try another one. All right, we have the square root of 252. So again, we're going to go ahead and use a factor tree. All right, and I'm going to say, what numbers go into 252? All right, and so I might look at this and I might go, well, I see 2 can go into it again. And then I would do, so if you need to pick up your calculator and you go, well, 252 divided by 2 equals, oh, that's 126. And I go, ooh, 6 can go into that. So 6 goes in that twice, so we get 21. Well, 6 isn't perfect, so we can branch off and we get 2 and 3, and 21 can branch off to 3 and 7. So again, I'm finding out what numbers make that number. So the square root of 252 is really 2 times 2 times 3 times 3 times 7. So when I look at this again, I say, oh, those 2's are in common and those 3's are in common, which would make the square root of 4 times the square root of 9 times the square root of 7. Well, square root of 4 is 2. The square root of 9 is 3. 2 times 3 makes 6. And then we're left with the square root of 7. So hopefully this helps you guys kind of figure out what to do with radical expressions and how to simplify.